2.3 Formulas and Problem Solving. So we're going to solve a formula for a specified variable. So why do we know how to do this? Later on in math and as you get down into your like STEM classes, formulas rule. So we have to know like, well, what if I'm only given these two things, but I need to solve for a random variable? So say we were given A equals LW. Say we needed to find the area, but what if we were just given the area and the width? So if we were only given the area and the width, we could find the length. But to find the length, we need to get L by itself. So it's very important for higher level classes of all types of like science and math. And so engineering is also science. So these are very basic formulas that we use a lot, right? Area is length times width, base times height, x times y. So we know area as a bunch of things. X and y might be a new one. X and just two variables, that's all it is. Simple interest is P times R times T, so that's principal times rate times time. Perimeter of a triangle, we know we add up all the sides, right? Distance equals rate times time, and volume of a rectangular solid is length times width times height. So a rectangular solid is like a rectangular prism or like a box. All right, so example 1. We have T equals M times N times R, and we need to solve for N. So what we're going to try and do to solve means to isolate. Isolate means by itself. So we need to get N by itself. So next to N, we have M times R. So it's M times N times R. So this is actually what we're working with. We're working with T equals M times N times R. Because remember, when variables are touching, they're multiplying. So we need to get M away from N. So to get M away from N, that's horrible, right? We need to divide it out, right? So don't we divide it because it's the opposite of multiplication? So we're going to divide by M. So that goes away. But we also have this R to worry about. So the opposite of multiplication is division. So we also need to divide by R. So when we do, we're left with T over M times R. So MR. And that equals N. We're done. Everything is solved for. N is by itself. That was the goal, to get it by itself, meaning nothing to the left, nothing to the right. So that's our solution. So what I want you to do, and again, I'm going to repeat myself a lot for the first few videos, is I want you to, for example 2, go ahead and pause the video, and I want you to try example 2. So solve for T, and it's very similar. So if you get stuck, look at example 1, okay? Okay, I hope you paused the video. If you didn't pause it, okay, hopefully you paused it and we're back. All right, so let's solve for T together. So what we're doing is we need to get T by itself. So technically we have A equals P times R times T. So the opposite of times is divide. So we're going to divide both sides by P. So that goes away. But we also have this R to worry about because we want to get T by itself. So we have R times T. So the opposite of times is divide. So we're going to divide by R. And that goes away. So what we're left with is A over PR equals T. And T is by itself, so that was our goal. We solved it. If you got it right, awesome. If you didn't, let's go back and see what happened. Look back at your paper and see what we went wrong. It's probably just this really, really tiny mistake. All right, example 3. Example 3 we're going to do together. All right, so we're going to solve. We have A equals 1/2 times base plus B times height. And we're going to solve for little b. Little b, lowercase b, it's all the same thing. I like to say little b. I don't know, it's cuter to say. So we need to get little b by itself. So parentheses, we do PEMDAS backwards when we're solving for a variable or solving for something. We usually do I like to think of PEMDAS backwards. So parentheses, we're going to touch last. So let's figure out what's on the outside of the parentheses and get rid of it. because what we're looking for is inside the parentheses. So parentheses you touch last. Now, I'm going to rewrite this just so we can work with it, and we have a nasty fraction. But let's try not to say nasty anymore, because they're not nasty. You know, just because we don't like to work with something or want to deal with it doesn't mean it's nasty. But that doesn't mean we have to or must work with it, right? We can avoid fractions. So to get rid of it, we just have to multiply it by its reciprocal. So we're going to multiply by the reciprocal. So the reciprocal is of 1/2 is 2 over 1, or just 2. So what we're going to do is we're going to multiply everything by 2, or 2 over 1. So we have 2 over 1 times a, that's 2a. We have 2 over 1 times 1/2. Those cancel each other out, so this actually goes away. And since there's no plus or minus right here, so in between right here, right there, since there's no plus or minus, all that we're left with is b plus little b. And that's all times, again, there's no plus or minus. So here, see how there's no plus or minus right here? So there's an h. You only distribute to terms, and remember, terms are separated by plus and minus, not parentheses. They're separated by plus and minus. All right, so let's keep going. We have 2a equals b plus little b times h, and again, our goal is to get little b by itself. So outside of the parentheses, we still have something. We have b plus little b times h. So the opposite of times is divide. So we're going to divide both sides by h. And when we do, we're left with 2a over h equals b plus little b. We can get rid of the fractions because after we get rid of the h, we're not left with anything. So we have 2a over h equals b plus little b. And remember, our goal is to get little b by itself. A lot of the times in math, we forget what our goal is. We just blindly just start working, and then sometimes we forget oh, what am I supposed to be finding? Keep in mind what you're supposed to be finding. Trust me, it happens. It will happen. We forget. All right, so we have b plus little b. So the opposite of, we have to get it by itself. It's not multiplying, it's a positive b. So we need to subtract by big B. So what we're left with, I'll bring it up here. What we're left with is 2a over h minus b equals little b. And that's it. We don't need to combine like terms. We don't need to subtract them. That is it. We are done. All right. So we solved for certain variables in a formula. Now let's actually use formulas. So we're going to use formulas to solve problems. Now this is just an interest formula. Now this is really applicable when we talk about interest and money and stuff like that, because everything you're going to learn in this class and college algebra about money is something that you need to pay attention to, because not only are you going to use it a lot in your adult life, but it's going to save you a lot of money. If you take me for college algebra, I'll go way more in depth about that, but anytime there's money involved, really pay attention to the example, because it will be applicable to your life, no matter what your major is. All right, so we have a equals p times 1 plus r over n to the power of nt. So Captain Zach Brannigan just received an inheritance of $10,000 and plans to place all the money in a savings account to invest in champagne company that he hopes will impress Leela. The account pays 5% compounded quarterly. How much will Zap have to invest after he gets back from the edge of the universe, which takes 3 years to travel from? What about 7.3% semi-annually? All right, so we're going to use the formula in white, the A equals P formula. And you're going to use this formula for your worksheet. So your lab worksheet for Chapter 2, you're going to be using a lot of that formula. Chapter 2 lab comes from 2.3 and 2.4 and 2.3 and 2.4. Mainly 2.3. All right. So with our formula, we have A equals P. So P is the principal. The principal is how much you're putting in. So P, that stands for principal, and that's your investment. So how much are you putting into this? he received $10,000 that he's going to invest. So P is 10,000. Awesome. Then we have R. R is the rate. So the rate is always like the percentage. So for the first one, we want to know if it's the account pays 5%. So we never ever use percentages. We have to switch them to decimals. So to switch this to a decimal, it's 0.05. How do you find that out? Divide 5 by 100. So 5 divided by 100, you get 0.05. All right, awesome. We found our rate. Now we need to find our N. N is attached to like words like compound or semi-annually or annually. It talks about how often are you doing this. So for our first one, it's 5% compounded quarterly. Quarterly, so quarter, there's 4 quarters in a dollar, so quarterly means 4. So we have our N. Now we just need to find time. So how long is this happening for? Let's look for the time. So he wants to invest it for 3 years. So our time is 3 years. Little t is always time. So that's we're gonna figure out how much we have in a return. So we have A equals P, which is 10,000, times 1 plus R. So R is 0.05 over N, which is 4, to the power of NT. So 4 times T, which is 3. You are going to need a calculator for this. So we're going to take it step by step with your calculator. I'm not going to show you, but I know you can do it. So we're going to do 10,000, 1 plus, so with your calculator, do 0.05 divided by 4, and you get 0.0124. And we know 4 times 3, it's 12. So now I'm going to add and combine like terms inside the parentheses. So we have 10,000. 1 plus 0.0124 is 1.0124 to the power of 12. So Pemdas, we have exponents. So we have to do 1.0124 to the power of 12. There's no way that we know how to do this by hand. You have to use your calculator. I mean, you are allowed to use any calculator as long as it's not an 89 or an Inspire. So if you only have like a cheap little calculator, it can still, as long as it does exponents, you're good to go. But you should have a TI calculator. So we do 1.0124 to the power of 12, and we get 1.0251625. Now we need to multiply by 10,000. So when we do, we get 10,251.56 So he's going to earn, after 3 years of this investment, he'll have $10,251.56 left in his bank account. So if he started with $10,000, and he ended with $10,251.56. That means he earned $251.56 after sitting on that for 3 years. Whoop-de-doo, right? All right, so that was the first part. Now we want to know, everything's the same, but what if he chose an account that was 7.3% and it was semi-annually? Because like there's multiple accounts and multiple banks and multiple offers that you can kind of juggle. So what's going to be the best for you? Let's figure it out. All right, so everything's the same except our rate and our N. So everything is going to be the same, but our rate and our N. So our rate is 7.3%, which is 0.073. And then our N, it changes to semi-annually. So semi-annually, semi means 2, right? So 2 times a year. So 2 times annually, so 2 times a year. but everything else is going to be the same. So let's plug it in. Let's plug it into what we already have. So we have A equals 10,000 times 1 plus n, and our n this time is 0.073. Sorry, wrong color. And that's over time. So our time, it was 4, our compound, but we're going to compound it semi-annually now. So semi-annually, that's 2 to the power of n. So that's 2 times t. The t is not changing. We're still doing it for 3 years. All right, this is where I want you to pause the video and type this into your calculator, how I showed you step by step, and let's see if we can get the same amount of money. All right, hopefully you pause the video. So let's go ahead and work this out. Remember, parentheses first. So we have 10,000 times 1 plus, now with our calculator we do 0.073 divided by 2, and when you did that, we should get 0.0365 to the power of 2 times 3, which is 6. Now we're going to add inside our parentheses, and when we do, we have 1.0365 to the power of 6. Now we need to do to the power of 6, so 1.0365 to the power of 6, and we get, I'm going to bring it up here, 10,000 times 1.239983307. Do you notice I don't round at all? I take all the decimals I can. Now we're going to distribute, and when we distribute, so 10,000 times that really long decimal, we get 12,399.83307, and that comes out to, remember, we're talking about money, so we're going to round to the nearest tenth, so $83. So to find that change, right, we started off with 10,000 and we ended with $12,399. That means we earned by interest $2,399.83. That's how much they earned. So obviously, you know which one's the better one, the 7.3% semi-annually. Oh my gosh, that payout is way bigger. So you see how important that was? $2,000 and $200. That's a really big difference. See, it's very applicable. All right. Example 5. The fastest average speed by a cyclist across the continental U.S. is 15.4 miles per hour. If they traveled a total distance of 3,107.5 miles at this speed, find their cycling time. Write the time in days, hours, and minutes. And that's from the Guinness Book of World Records. This is real information. Anytime I'm going to give you some type of fact like that, it's usually going to be straight up and real. All right. So this is a word problem. Now, the example 4, it technically is a word problem, but we can pick out variables, like P is this, R is this, T is this. Example 5 is a little less straightforward, so we're going to do those few steps of understand, translate, solve, stuff like that. So our first step is to understand, meaning we have to come up with some type of formula or something. So we're talking about speed and distance, because it says the fastest average speed is this, and it says the distance is this. So we know, because it says distance and speed, that we're talking about distance equals rate times time. Rate is the speed. That's how I got that, because we're talking about distance and speed. So distance and speed, that's why we're doing that. Also, isn't it asking find their time? Can't we do that? Because we have distance, we have speed, we can find time. That's why we're using D equals RT. So our second step is to translate. So to translate what we're given, so we have to fill out this formula now. We have the distance, it's 3,107.5. That's lambda, that's horrible. There we go. And we're given the rate. the rate is 15.4 miles per hour. So all we have to do is just plug it into our formula that we have. Or if we know we have to solve for t, we could solve for t and then plug it in. So it's up to you. I'm going to solve for t and then plug it in. So we know we need to find t. That's our goal. We need to find time. So to find time, I'm going to divide by r. So we'll have distance over r equals time. So distance over rate equals time. Doesn't that make sense though? How long you go and the rate you're going, that's how long it will take to get there, right? So now I'm going to plug it into this formula right here. So we have distance, that's 3,107.5 over the rate, which is 15.4. And that equals time. We use our handy dandy calculator. We have 201.79 hours. But it wants it in days, hours, and minutes. That's not days, hours, and minutes. That's 0.79 hours. That doesn't tell me how many days, hours, or minutes it took me. That just tells me how many hours it took me. That's not okay. We need days, hours, minutes. Because if someone told me it took them 201.79 hours to travel across the country, I would be like, what? How? Tell me in days. That's what I understand. So that's why we're going to switch it to days, hours, and minutes. So to switch it to days, how many hours are in a day? 24, right? 24 hours are in a day. So we're going to divide 201.79 by 24 hours. And when we do, we get 8.41 days. So we're there. We have 8 days now. So it's 8 days. All right, now we already accounted for the 8, so we're left with 0.41 days. I have no idea what the heck 0.41 days stands for. So instead, we're going to figure out how many hours is in a 0.41 of a day. So 0.41 days by how many hours are in a day? That's 24 hours in a day. So 0.41 times 24, and we get 9.84 hours. So 0.41 of a day is 9.84 hours. So we have 9 hours. So now we're left with 0.84 hours. We need to switch that to minutes. So there's 60 minutes in an hour. So 0.84 times 60, and it's about 50 minutes. So 207.71 hours is about 8 days, 9 hours, 50 minutes.